So we have graphed sine, cosine, and tangent, and we have changed the period and the amplitude, or the stretch if we're talking about tangent. So we're going to add the translations in there. We've done transformations for every function that you can think of, right? Like everything, so it pretty much is the same, right? It pretty much works the same. It says, like other functions, trigonometric functions can be translated. Given the functions to the left, written out over here, the C represents, what does C do? That's left to right. So this is our horizontal shift. And then the D is vertical shift, which could be up or down. So the C is the left to right. And remember that X lies, right? Just like B, you have to divide by B. You're not multiplying by B. So with that negative there can throw you off on the C. So the vertical shifts, if it's plus, that means it's going up. Minus is down. For C, if you see plus C, that means you're going which direction? Left. And minus means right. Okay? Just like it has been, you've been looking at these shifts since Algebra 1. Okay? Just haven't done them with trig before. So very simple questions, 1, 2, 3, and 4 here. Cosine of x plus 2. What does that translation look like? Up 2, because there's not in parentheses there. This is a plus 2, so this is up 2. This here, tangent of x minus 1 would be down 1. No, it's fine. We'll just up and down. So sine of x plus pi halves. Left pi halves. And then cosine of x minus pi means we're going to do right pi. So your left and right have to have some sort of pi on them because those are your angles, and that's how your axis is, if you remember. So when you shift the graph vertically to create a new horizontal axis, so when we were graphing these, we were counting a lot from the axis. But when you shift it, you lose the axis, right? So it creates a new one called the midline, because it's in the middle and it's a line. Okay? So this is your x-axis, and this is y equal, or f of x equals the sine of x. This is sine of x plus 4, so it got shifted up 4, right? So this is your midline now. And what is the equation of that line? Y equals 4, exactly. It's that easy. See how these numbers match? So it says this is the reference line to which the graph oscillates. Oscillates means like going up and down. So the equation for the midline is just going to be y equals whatever that vertical shift is. It's that easy. And having the midline actually helps you with the translations. It kind of simplifies things more so than it did with the others. There were definitely some translation or transformations that we did that were kind of tricky. These really are not that bad. They look weird, or they look horrible because they're so much repetitive, but it's repetitive, and that's really good news. So let's do a couple of these. So it says graph the function, then identify each characteristic. All right. Well, it's really easy to identify the characteristics first. So let's look at what we have. What is the amplitude of this? 3 halves. Good. 3 halves. What is the period? Okay. Phase shift. Phase shift is your horizontal shift. Is there one? No. So this is none. We have a vertical shift up 3, which means that the midline is y equals 3. So you come over here and you sketch the sine parent function, which is that. Do it. It's not going to kill you. You need it. Okay? The next thing you sketch in is the midline, y equals 3. You sketch it in as if it were an asymptote. It's not an asymptote, and it's not really part of the graph like an asymptote is, but if it's sketched in there, even if you leave it, it's fine. Okay? Because here's the good news. If you just pretend like that midline is your new x-axis, this part takes care of itself. And it's not even part of anything you have to worry about. So when you go to graph sine, here's what you should do. We know that for the parent function, and without any shifts, it starts at 0, 0. So that's where we start putting our pencil down, but our new 0, 0 is right here because our x-axis changed, right? So I'm not making a point there, I'm just putting my pencil there. And then I see if there's any sort of shift. There is no phase shift. I'm not going left or right. the vertical shift has been taken care of because of the midline, and so that is my point. Okay? Basically, I took it and shifted it up 3, but the midline did that for me, right? The next part you should always graph, because this gets a little bit trickier when you actually have shifts in there, is the end of the period. The period is 2 pi long. So I'm at 0 right now, so I go to 2 pi, and this is an intercept just like the first one was. The part that people keep missing, I'm not sure why, but the next thing you have to do is the middle, which is another intercept. So at pi, I have another intercept. Yeah. So then halfway in between these two, for the parent function, we're at 1. You gotta look for a reflection too. There's no reflection, but it would be 1 for the parent function, but we have this amplitude of 3 halves. So halfway in between, from the midline, you go up 1.5. Halfway in between these two, from the midline, you go down 1.5. Do you see how the midline just takes care of your vertical shift for you? Then at this point, lather, rinse, repeat. Right? So I have an intercept here, and it happens every pi in this particular case. And then I alternate up and down. And then it looks like this. Try and make it curvy and not so pointy. And you have to have arrows on the end, because we are going to graph some that actually stop, and these do not. Questions? Now, some of these that we're going to do, there's a whole lot of, different things you have to do on there, and you may not graph as quickly as I do. If I move on and you're not done, don't stay there and finish the graph. Make sure you have enough of it done that it makes sense to you. You can always go back and finish it and move on with me so I don't lose you, okay? Because I know I'm not going to give all of you enough time every time, because if you graph slower, or if you don't necessarily graph slow, but you messed up and you had to erase, then you're behind. And it's fine. If you can't finish it 100%, make sure you understand what needs to be finished, and then we'll move on so we can get through more of these. All right, so let's look at this one. Amplitude. Well, does tangent have an amplitude? No, but this number that's right here, which there's nothing, so actually there's a 1, I still need that number, right? So it's not really an amplitude, but that 1 is still a number I have to use. What is the period here? For tangent, it's just pi. For tangent, it's just pi, and it doesn't change because there's not a number there. Do we have a phase shift here? Yes. We're going to go which direction? Left, pi halves. And a vertical shift, none, which means your midline is y equals 0, but that's the axis, so we don't have to worry about graphing it in. We need to sketch the parent function of tangent, which is pieces and looks a little weird, but these are the pieces you want, trust me. Otherwise, it makes everything else way more confusing when things get weird. Okay, so that's the parent function part of that. So we start with knowing that for the parent function, you start at 0, 0. So you might have a new 0, 0 if you have a midline. We don't, so I have this same 0, 0. But I have a phase shift. From here, I have to go to the left pi halves. That's where this starting point of my period is. Does that make sense to you? Okay, so then I want to do the end of the period. The period is pi units long. I have pi halves to get back to the axis, so I go pi halves on the other side. That's a full length of pi. Or you could count it out because each one's a fourth, right? 1, 2, 3, 4, pi. So that's the beginning and the end. Then I need the middle. The middle, right in between, is an asymptote. Put that in there. So that's this. Then, halfway in between the first intercept and the asymptote is this point here, which is 1 for the parent function. And because there's no stretch or compression, it's still 1. So halfway in between these two, I go up 1, and it would be from the midline, which happens to be the axis. Between these two, I go down 1. Then if you look at those 5 key pieces, do you see how you have something on every single x value that's marked off? So then repeating this should be pretty simple, because you're not having to count in between there. You just have to make sure that you're alternating and getting all the pieces in there that you need. Yes, you should have a last little part, as much as it can fit on that grid. How are we doing right now? Any questions? Because the next one is a little wacky, but it's kind of the wackiest of them. The ones that get weird is when you can't fit the whole parent function on there, and that's what's about to happen here. So, okay. Are we good? What do you need? I got more pencils. Oh, I got more pencils right there. All right, let's move on to the next one. Hopefully, you at least got enough of that graph where we can move on. All right. So, number 7, what is the amplitude? 4. Yes? Okay. What is the period? Okay, I'm going to take 2 pi and divide it by that, right? Doesn't that mean that I take 2 pi and I actually multiply by 3 over 2? So those cancel out and I get 3 pi. If you need to write this down so you don't mess it up, write it down. That's fine. Right? You don't have to do it in your head. All right, do you have a phase shift here? Yes, we're going to the right pi. Do you have a vertical shift? Yes. Up 1, which means your midline is y equals 1. So I go here to y equals 1. I'm going to draw in my midline. Right? That's now my new x-axis. I'm also going to draw my parent function here that looks like this. This is cosine, right? Everybody with me so far? All right, so for my parent function, I would start at 0, 1. But because of the amplitude, I would start at 0, 4. Make sense? My new 0, 0 is at the midline, so from the midline, I would go up 4, but then I also have a phase shift to the right pi, and that is where my first point is. Okay, do I need to walk you through that again? I start at 0, 0. I have to go up 4 because of the phase shift. I'm sorry, because of the amplitude. And then I go to the right pi because of the phase shift. So that's this point right here. That's my new point there that got transformed. We all okay with that?
That was on like the y-axis. Is that the y-axis?
Pretty much, yeah. Okay, so then what we normally want to do, listen, we normally want to do the end of the period. Well, the period is 3 pi. So I'd have to go 3 pi from here, which would put me at 4 pi, which is way the heck out there, and I can't do that, right? But let's think about what we have. This would be at 3 pi. You agree with that? Okay, and this is at 0. So what is this? It would be halfway. 3 pi over 2. See how easy it is to divide by 2? 3 pi over 2. Okay, but it's 3 pi over 2. Listen, it's 3 pi over 2 from here. Okay, and that goes way off of that as well. You with me? Okay, so then let's think about this. Don't overthink this. This is really easy. If this is 3 pi halves, what is this? 3 pi fourths. This is 3 pi halves. If you want half of it, you multiply it by 1/2, it becomes 3 pi fourths. Make sense? Yes, you sure? Yes? Okay. Okay, so the distance here is 3 pi fourths, which is 3 spaces, yes? To go from this point to a point that would be an intercept, but it's actually going to be on my midline. So I can go 1, 2, 3. That's 3 pi fourths. Here's that point right here. I just plotted this point right here. You with me? Now, everything is symmetric and everything repeats. If the distance from here to here is 3 pi fourths, what is the distance from here to here? And from here to here? And from here to here? 3 pi fourths. I only have 2 points on there, but you know what? I know what cosine looks like. I can keep repeating, because although I don't even have to draw it out over here, doesn't it go like this? And wouldn't this, if this is 3 pi fourths that way, isn't this one 3 pi fourths this way? So from this point, I can go 1, 2, 3 pi fourths. There's another intercept. And then when I go to the left, 1, 2, 3 pi fourths, and I go down. How much? 4. 1, 2, 3, 4. Right? And then I go to the left, 1, 2, 3 pi fourths, I'm back at an intercept. To the left, 1, 2, 3 pi fourths, and I'm back up here. But you have to be able to think fractionally. It's not that hard. You can do that. Think basic. Don't try and make it complicated. There's no reason to make it complicated. And then you just sketch this in. And the only reason this one ended up being weird is because you couldn't get that whole first period on there. The rest of them aren't as bad, but that's going to happen. And if you understand, it's okay. I don't have to get all 5 pieces on there. I just had 2 of them and I could figure the rest of it out, right? Because everything is symmetric and it repeats and it's half, 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 half. We good? All right. Let's look at number 8. Do I even have an amplitude for tangent? No, I do not. But I have a special number that goes right here, and this one happens to be 1. Right? What is the period here? Pi halves. Okay, because I got to divide it by that. We understand why it's pi halves? Okay. Do I have a phase shift? Yes, I'm going to the left, pi fourths. Vertical shift, down 3. So my midline, y equals -3. So I draw in my midline, draw my parent function. For my parent function, I start at 0, 0. This is my new 0, 0. I then have a phase shift to the left pi fourths, so this is where my first point goes. Okay? The end of the period is another intercept. The period is pi halves long. That's 2 pi fourths, right? So 2 of those, there's the end of the period. Okay, everybody okay with that? Then the asymptote is between the 2, which would put it right on the axis. There is no reflection. Halfway between the intercept and the asymptote, I have to put a point, which is 1 for the parent function and is determined by this number, which happens to be 1. So halfway in between these 2 is literally a half, and you go up 1. Then halfway in between these 2, and you go down 1. Okay? Then when you start to repeat stuff, do it methodically, like whatever makes the most sense for the one you're on. If you notice the intercepts, it goes intercept, asymptote. So then it's going to go asymptote, intercept, asymptote, like over and over. So you can repeat all that, and then you can go back and put the up and down ones in. So I'm going to put the asymptote and an intercept, asymptote, intercept, and so forth, because it's going to be a lot to draw on here. And yes, you're supposed to do all of them. You're in the wrong class. It's just a dotted line. It's just like drawing a line. I'm just dotting it as I go. Okay, and then up, up, up. Not that bad. It could be worse. They could be all different every time, but it's just a repeat, repeat, repeat. So I know this one in particular is going to take some of you longer because you're going to try and make it perfect. So get a few of them drawn in. Know that you're supposed to repeat it, and then we need to move on. Yes. That's fine. All right. Get a couple of them, and then let me know when you're ready to move on. Don't. We need to, because they're all different. We got different stuff for every single one. Yeah. Okay. Can we move on? Those of you that are still drawing, can you give it up at this point? Okay. Let's look at 9. What's the amplitude on 9? 3. What is the period? Pi halves, because we have to divide it by 2 pi, so it's pi halves. We have a phase shift to the right, pi halves, and a vertical shift down 2, so y equals -2. All right. So this is sine, this is my parent function, and y equals -2 is my midline. I know, but different things happen every time. All right, so I start here normally at 0, 0, right? So I'm here, this is my new 0, 0. But I have a phase shift to the right pi halves. My vertical shift is already taken care of. That's my first point right here. The next thing I want to do is the end of the period. The period is pi halves long. That's 2 pi fourths, so this is the end of the period. Then you do the middle, which is another intercept right here. Okay? Then halfway in between would be a maximum because there's no reflection. The amplitude is 3, so halfway in between from the midline you go up 1, 2, 3. And then halfway in between from the midline you go down 1, 2, 3. Then you repeat. There's an intercept on that midline. It's not really an intercept anymore, but every single x value. So those are easy to fill in. And then you just alternate with up and down for the other ones. And yes, you have to draw it. Nope. Oh, your hand won't fall off. You will be fine. You're in the wrong class if you think this ain't even much. Goodness gracious. So maybe those of you that told me calculus, that's probably not for you if you can't handle even this. Yeah, no asymptotes here. This isn't that bad once you. Maybe. We're still working on it. Well, because it hasn't been done before, and Ms. Tremont and I are fighting for it and stomping our feet really loudly, and we'll see what happens. All right, how are we doing here? We good? Okay. Give me my eraser back. Okay. All right, let's look at 10. What's the amplitude here? It's 1. What's the period? Pi. The phase shift, I'm going to the left 3 pi fourths and up 4. So the midline, y equals 4. Cosine, oops, looks like this for the parent function. Midline is y equals 4. Okay? So I start at 0, 1, right? So at 0 is really my new midline, up 1. But my phase shift is to the left 3 pi fourths, so I go 1, 2, 3 pi fourths. There's my new point. Always look at your scale. They're all spaced by pi fourths, but it's possible you could get a graph where it's not, so just make sure you're not making stuff up. Then the period is pi. From this point, this is this point, I need the end of the period, which means it's going to have the same y value, but it has to be pi units away. So that's 1, 2, 3, 4 pi fourths, which is pi. There's the end of the period. Halfway in between these two, I get my minimum. So halfway in between gets me here, but I go 1 below because that's the minimum. Halfway in between these two gets me an intercept, which is really just on the midline now. And then halfway in between these is another intercept. There are my 5 key points, and you can repeat. Okay? Everybody okay with that? We good? There you go. That's what it should look like. It's possible, not for me, but I'm sure it's possible for somebody, but it ain't possible for me. Okay. All right. Any questions at this point? Good. All right, let's look at 11. What is the amplitude? Do we have an amplitude? Yeah. Tangent doesn't have an amplitude, so has a vertical. So I'm going to mark it out. I still need to worry about the vertical stretch, which is 2, because that number is important to me. We just don't get to call it amplitude. What is the period here? 2 pi. Good, because when you divide by 1/2, that means you're multiplying by 2. Y'all got that? We have the phase shift. We're going to the, which way? Left pi, up 1. So midline is y equals 1. Tangent parent function looks like this. And I draw in my midline, which is at y equals 1. Okay. All right, so I start on the parent function. It starts at 0, 0. This is my new 0, 0. I have a phase shift to the left pi, so I go to the left pi, make a point, because the vertical shift's already taken care of. The next thing I want to do is the end of my period. The period is 2 pi long. So it takes me pi to get back to the axis, so I go another pi on the other side. There's the end of the period. So the length there is 2 pi. Halfway in between, asymptote, which this happens to be on the axis. Okay? Halfway in between the intercept, which is now on the midline, and the asymptote, I have a point at 1, but the vertical stretch of 2, so halfway in between from the midline, I go up 2. Halfway in between on this side, from the midline, I go down 2. There are my 5 key points, or 5 key pieces. Then you can repeat. So it's every other x value that's marked off that we have something. So I skip 1 and go up here, and skip 1 and have an asymptote. Skip 1 and go down here, skip 1 and have an asymptote. And this is what this graph looks like. Okay, any questions at all? I'm not sure if I put any on these or not. Maybe. They're just reflections, but I don't think starting up. There's one. There's just one. Okay, there's just one. Lots of things. We'll get there. We got to get them down before we can worry about any of that. All right, so I'm going to give you this assignment. I have it due next Wednesday because I don't see you Monday or Tuesday. Y'all don't have school. Because I'm not going to, because I'll see you tomorrow, but then I know that y'all aren't going to go home and finish this tonight. Some of you may if you're responsible. But if you have questions on Wednesday, if you made an honest effort and most of it's done, but you have some questions or you're confused, if you talk to me individually, I'll give you another day to finish it because I want you to learn it and understand it, not just scribble something down to get a grade. Does that make sense? But I'm also not just going to extend it because you're a procrastinator. Okay? Come into Mav time, try and get it figured out. Like, you need to be able to do this because then we're moving on to other stuff and this just is going to keep compounding. You can't blow it off. Okay? The other thing